Hi friends, how are you? Let's look at problem 3837. Delete count of equal elements. In this video, I'm going to solve it using dictionary plus bisect. So here the problem statement is very short. We are given an array called nums of length m, and also we are given an integer key. So for each index I, it corresponds to a number, right? So we want to define the delete count as the number of indices j such that I is strictly larger than I plus k, right, up to the end. And also we want these indices corresponding to the same element as the nums I. So we want to return an array where answer I is the delete count for index I or for the number at index I, right? So here we have two examples. Let me give you a quick overview of example 1, right? And also we want to use this overview or walkthrough to demonstrate our main logic. So here, actually you can first make a dictionary. So for example, using the unique value as the key and the corresponding indices of this value as the value. So here 1 appears in index 0, 2, and 3. So you get 0, 2, and 3. And the 2 appears at index 1, right? So now we want the result to be something like 0, 0, 0, a length 4. So we want to modify those numbers, right? So here first at I equals 0. So the number is 1, right? Then we use this dictionary to check the 1. So because 1 corresponds to 0, 2, 3. Those are the indices corresponding to 1. And then I want, because here k is 1, so I want the indices is greater than 0, that is I, right? I plus k, that is 1. I want it to be strictly greater than 1. So here, these 2 and 3 are strictly greater than 1. Therefore, here I should write a 2, right? So as long as how you get this 2, so you can do an insertion, right? Insert 1 into 0, 2, 3, right? And then the insertion index will be 1, right? It means that to the left there are 1 element, but the length is 3, so you're going to get the 3 minus the insertion index, that is 1, so you get 2. So similarly, you can look at the 2 here. At I equals 1, so y equals 2, right? So the dictionary corresponding to 2 is this one. The list is this 1, right? So I want all the indices j to be strictly larger than 1 plus 1, that is 2. But here, if I insert, so I get to the very right, right? So all the element is actually less than 2. So therefore, this corresponds to a 0, right? Similarly, you can decide the other 2 are 0. So that's the way we're going to code this problem. But from this walkthrough, you see there are 2 ingredients. First, I need to get this dictionary. So this is rather simple, right? And then once I get this dictionary, I need to have a way to quickly get the number of indices which is less than or equal to I plus k. And then all remaining ones will be satisfy this one. It just returns the count. So this is exactly the bisect plays the role. So with that said, I guess it will be rather straightforward to do the coding. So before I do the coding, you can look at this constraint. The first one determines the problem size, and this one is not that essential. And this one basically tells it's a consistent assumption, but you can k can be very large. If k is greater than n minus 1, then you will just return all zeros, right? So now let's look at the coding. First, I'm going to get a dictionary. So the dictionary will be collections and default dict. So I'm going to use list as a container, right? So basically, we want to get this information first. So this is a dictionary, right? So what we can do is that we can do a for loop for I, y in enumerate this nums, and then d of y. So we're going to append I, because we are going to scan the list from left to right. So we always maintain this dy, the list, sorted, right? So then let's prepare the return. First I get the list nums, and the delete count would be, first let's initialize this to be here. Actually, you don't need to initialize, you can just append, right, for after you compute each one. So basically for I, y in enumerate nums. So first I get the information. So here we get y. So the insertion I want to check is I plus k, right? And then the IDX, let me first get the insertion point, is bisect. So here I'm going to use bisect right. So the guy we're going to check is dy. So the insertion point will be k, right? And you can put this here, replace p by I plus k to make it more compact, right? So this way, left to this IDX, all the indices will be less than or equal to this number, right? Then what the delete count for this I would be the length of dy minus this IDX, right? So if this IDX is very large, for example, at the end of this one, then this will be 0, right? So then we just need to return the delete count. So that's the full code actually. So you can do a run first. Yeah, it passes the 2 test cases, and then let's submit for generic case. Yeah, it passes all the cases. So here actually you can print out this information for better understanding, right? So you can see what's the D, right? And here you can print current index. It's going to be I, right? And the number is going to be y, and delete count is going to be delete count I, right? So you can print this out, right? So you can get all the information for example, example 1. So you have I is 0, num is 1, the deleted count is 2. So I equals 1, nums is 2, deleted count is 0, so 0, 0. So for case 2, so 0, 3, 1, 0, 3, 1, and 1, 1, 1, 1, 1, 1. So 2, 3, 0, 2, 3, 0, 2, 1, 0. Of course, you can also print out all those information if you like. But let me comment out this to recover the original code so that you can copy or follow. With that said, I guess that's it for the current video. Thank you for watching.